May we start, sir? Chavan, sir.
Yes, sir. Yes, sir. Wish you all the best.
Okay, sir. Thank you, sir. A very good afternoon, everyone. I, Mr. Balasaheb Kale, extend you a very warm welcome on behalf of Department of Chemistry and IQAC, Sri Venkatesh Arts, Commerce and Science College, Deolgaraja. I take this opportunity to welcome our resource person, Honorable Dr. Nirja Dashputre Ma'am, Principal Technical Officer, IZAR Pune, and our IQAC Coordinator, Honorable Dr. Sudhir Chavan sir, and all the participants to this online workshop on effective pedagogical tools and techniques for improved learning outcomes, organized by Department of Chemistry and IQAC of our college. Sri Venkatesh College is one of the prestigious colleges in our area, which is run by Sri Balaji Samsthan Deolgaraja. Our hereditary trustee, Honorable Raja Vijayan Singh Jadhav sir, has embraced quality and innovation favorable for the overall development of the students. So, without taking much time, I would like to invite Mr. Professor P.M. Kadam sir to deliver the introductory remark and to introduce today's resource person, Honorable Dr. Nirja Dasputre ma'am.
Thank you, sir. So, Honorable President of College, Raja Vijay Jadhav, Honorable Principal of our college, Dr. D. Kore, sir, IQAC Coordinator, S.D. Chavan, sir, and today's resource person, Dr. Neeraja Dashputre, and all the participants. Good afternoon to all the participants. I welcome on behalf of Department of Chemistry and Sri Venkatesh College, Deolgaraja. Dear participants, we all know the education system is gone through the lot of transformation over the past many decades, and since last 2 years after the pandemic of COVID-19, we have seen it how the transformation has come from the classroom teaching to the online teachings, and nowadays the technology is mostly used in the teaching, and various organizations like Byju's, Vedanta, and Unacademy are focusing more on use of this technology in the teaching. So this has been only possible because of new pedagogical practices that have also involved with the changing the world around us. So after this pandemic situation, many of our teachers are facing a problem like lack of concentration, and the students in the classroom, they are not very interested for the learning, and the process of learning is not very much important to them. So along with the classroom teaching, we have to adopt these new pedagogical tools and techniques to make this learning more interesting and student centric. So employing the effective pedagogical approaches helps the students achieving learning outcomes and they realize their full educational potential. So quality pedagogy provides a strong foundation for learning. It helps students in developing advanced concepts and abilities. Also, the right pedagogy enables instructors to observe the academic process of their students. So in order to build a strong education system, we need to apply the pedagogical tools that have proved to be effective worldwide nowadays. So in today's workshop, we will learn some effective pedagogical tools and techniques which will be beneficial to all the faculty members which are present here. So I will now introduce our today's resource person. So it's my privilege to introduce our resource person. So today's resource person for this workshop is Dr. Neeraja Dashputre. So Neeraja Dashputre completed her undergraduate studies in chemical technology from Institute of Chemical Technology, Mumbai. During her doctoral studies in organic chemistry at University of Maryland, USA, she recognized her love for teaching and completed the university teaching and learning programs. She later worked as a faculty at Claremont University, USA, and is currently working as a principal technical officer in education department at IZAR Pune. She has keen interest in developing inquiry-based pedagogy for teaching chemistry. She loves participating in various science workshops as a workshop trainer and interacting in students and teachers alike. So I welcome such a multi-talented personality, Neeraja Dashputre, madam, for this workshop. And again, as a coordinator, I welcome all the participants of this workshop.
Thank you, Pawan sir. Thank you, Savant sir, बिराडे सर आणि काळे सर. सगळ्यांना थँक्यू मला बोलवल्याबद्दल इथे आणि तुमच्या सगळ्यांशी बोलायला मला खूप आवडेल.
Thank you, sir. After this brief introduction, I would like to invite our resource person, Honorable Dr. Nirja Dashputre ma'am, to please deliver his speech on effective pedagogical tools and techniques for improved learning outcomes.
थँक्यू काळे सर. सो सगळ्यांना मनपूर्वक धन्यवाद. एकतर व्यंकटेश कॉलेजचेच मी आभार मानते मला बोलवल्याबद्दल. मी आज थोडस तुम्हाला कदाचित तुम्ही माझं हे लेक्चर आधी ऐकलं असेल. जर का तुम्ही आयसरचे काही प्रोग्राम्स अटेंड केले असतील तर कदाचित काही भाग ओव्हरलॅप व्हायचा शक्यता आहे. पण थोडस माझ्याविषयी सांगते की मी आयसर मध्ये जे काम करते ते काम हे रिसर्च करणं आहे. पण शिकवायचं कसं, हाऊ डू यू रिअली टीच सायन्स, हाऊ डू यू रिअली टीच केमिस्ट्री, and research on education research on that front is what I do at ICER Pune. So we also have a couple of programs running. One of the core programs running for undergraduate teachers right now is called as MS DEED, and those of you who haven't yet joined us for any of the workshops, we really request you to join us. मी नंतर कदम सरांकडे त्याचे सगळे डिटेल्स पाठवते. सो सुरू करूया आपण आजचं टॉक. मला एक विचारायचं सगळ्यांना, इज इट ओके इफ आय स्पीक इन इंग्लिश, or do you want me to speak in Marathi, or do you want a mixed language? Which one is preferable?
Please be bilingual, ma'am.
Bilingual is better. Okay.
Yes, bilingual is better. Yeah.
थोडासा मध्ये इंग्लिश मध्ये बोलीन, मध्ये मराठी बोलीन. आणि अजून एक रिक्वेस्ट आहे सगळ्यांना की जितकं तुम्ही बोलाल तितकं लेक्चर किंवा आजचा टॉक चांगलं होईल. सो वी रिअली रिक्वेस्ट एव्हरीवन टू पार्टिसिपेट. द आयडिया हिअर इज टू शेअर आवर एक्सपिरियन्सेस इन क्लासरूम्स, share our problems, and also share the solutions, and together if we can find solutions to our problems is the idea. So जेवढं तुम्ही बोलाल मला खूप ऐकायला आवडेल. एक प्रश्न होता, आपण एक हा व्हॉट्सअप ग्रुप वरती मी एक पोल घेतलेला की किती तुमच्या वर्गात तुम्ही किती बोलता आणि मुलं किती बोलतात. तर त्याच्यापैकी बऱ्याच जणांनी असं लिहिलं की मुलं तेवढंच बोलतात जेवढं मी बोलतो, किंवा माझ्यापेक्षा जास्त बोलतात कधी कधी. तर आता आपण सगळे तेच फॉलो करूया. आय वुड रिअली लाईक टू लिसन टू ऑल ऑफ यू एज वेल. ओके, सो मी स्क्रीन शेअर करते सगळ्यांना. एकच मिनिट. सगळ्यांना स्क्रीन दिसतोय का मला फक्त सांगा. सगळ्यांना माझा स्क्रीन दिसतोय?
येस मॅम.
ओके. मी कदाचित माझा व्हिडिओ बंद करीन जर का इकडे बँडविड्थ खराब झाली तर स्क्रीन दिसत राहील तुम्हाला. ओके. सो आज आपण बोलणार आहोत की पेडागॉजिकल टूल्स म्हणजे शिकवायचं कसं, आणि त्याचे काही आपल्याकडे छोट्या छोट्या युक्त्या आहेत का आणि काही टेक्निक्स आहेत का ज्याच्यामुळे मुलांना शिकायला मदत होईल. Effective pedagogical tools for improved learning outcomes. How can we make our classrooms better by changing some of the techniques or some of the ways in which we teach is the whole idea for today's talk. And many of you would be using these things. I'm pretty sure that some of you are already using these things. Some of you are already probably doing way more than what I'm going to talk today. But it will be, as a summary talk, I think I have tried to include many pedagogies that will work for sciences, engineering, and some social sciences as well. So let's begin with today's talk. So what do we mean by effective pedagogy? Before we start the talk, we need to understand that pedagogy, the word pedagogy means a method, or खूप पूर्वी जे ग्रीक साम्राज्य होतं त्यावेळी पेडगॉग्स असायचे. पेडगॉग्स कोण होते की जे शिष्याला गुरुपर्यंत पोचवायचे किंवा शिष्याला ज्ञानापर्यंत पोचवायचे. So now here, when we are talking about effective pedagogy, here we are talking about methods, right? So methods that will take our students from where they are right now to where we want them to reach, where we want them to be. So pedagogy चांगली कोणती असते, तर ती pedagogy चांगली की ज्यांनी मुलांना खरंच शिकायला मदत होईल. सो इफेक्टिव्ह pedagogy इज इफेक्टिव्ह लर्निंग. तुम्ही समजा इकडे हे छोटंसं कार्टून आहे ते पाहिलं, तर त्या कार्टून मध्ये तो मुलगा म्हणतोय की मी माझ्या कुत्र्याला शिट्टी वाजवायला शिकवलं. आय टॉट हिम हाऊ टू विसल. द अदर किड सेज आय डोंट हिअर हिम विसलिंग. मला ऐकू येत नाहीये तो काय म्हणतोय, तो शिट्टी तर वाजवत नाहीये. तर तो पहिला मुलगा म्हणतो आय सेड आय टॉट हिम, आय डिडंट से ही लर्नड इट. सो असं आपलं होऊ नये, असं आपल्या वर्गात होऊ नये की मी तर जाऊन शिकवतोय वर्गात किंवा मी तर जाऊन शिकवतेय वर्गात, रोज मी लेक्चर घेतो, खूप छान प्रयत्न करतो, बट माय स्टुडंट्स आर नॉट लर्निंग. If that or my students are unable to do some tasks that I want them to do, if that is the case, then we need to change the way we teach them. We need to change the pedagogy with which we teach them, because if it is not helping them learn, then the pedagogy is not effective, right? And in some sense, we now need to focus more on what improves learning rather than what improves teaching. As a teacher, I need to be more concerned about my students learning than my ways of teaching. आणि ते शेवटी दोन्ही एकत्र बांधलेलं असतं. लर्निंग अँड टीचिंग गो हँड इन हँड. इट्स नॉट वन नॉर द अदर. सो वी हॅव टू try to teach in a way that brings in effective learning. So what is the teaching process? Typically, what is the way we do? First, we really decide what do I want my students to learn. Very often this is done by our syllabus, that in the syllabus it is given that students should learn XYZ, this topic in this sequence. It's very nicely chalked out for us by somebody else. But very often I need to ask when I'm going to a class, today what I want my students to learn. I will probably cover these concepts, but what should they be able to do at the end of it? That is learning outcomes, right? Then we identify best teaching practices. Like if I want to teach, let's say, titrations, what is the best teaching practice for it? Is it better for me to make them do the experiment? Is it better for me to do a lecture? Is it better for me to do a project on it? Is it better for me to, better for learning? Let's not say better for me. Better for learning, that they sit in groups and try to solve a problem. Which way will they be able to learn that particular topic in the best manner, right? So we identify best teaching practices. Then, of course, we plan assessments. If we have taught something, how do we know that the students have learned it? So very often it is not the final exam. वर्षाच्या शेवटच्या एक्झाम विषयी मी बोलत नाहीये, पण तिथल्या तिथे वर्गात आपल्याला बरेचदा फीडबॅक मिळत असतो की खरंच आज जे आपण बोललो त्याचा मुलांना कितपत समजलं, त्यांना काही प्रश्न आहेत का, किंवा एखादी छोटीशी फॉर्मॅटिव्ह असेसमेंट स्ट्रॅटेजी आपल्याला घेता येते की जेणेकरून तिथल्या तिथे मला एक फीडबॅक मिळतो की मुलांना खरंच कळलंय की नाही, राईट? सो हाऊ डू आय नो इफ माय स्टुडंट्स हॅव लर्न समथिंग? आफ्टर दॅट वी शेड्यूल अँड सिक्वेन्स द लर्निंग. कसं जायचं वर्गात, आधी काय बोलायचं, मग काय बोलायचं, कुठली असाइनमेंट आधी घ्यायची किंवा कुठला प्रॉब्लेम आधी घ्यायचा, सच दॅट इट मेक्स अ सेन्स टू आवर स्टुडंट्स. अँड देन इट कम्स व्हॉट टेक्नॉलॉजी वर्क्स बेस्ट. ओके, सो बरेचदा आजकाल कोविड नंतर असं झालंय की लोकांना वाटायला लागले की टेक्नॉलॉजी चांगली असेल तर टीचिंग चांगलं होतं. तर लेट मी try to burst that bubble here. Is that first 3 to 4 steps are very crucial. Only then we will be able to fit in the right technology. It is not the other way round. Okay, so पहिल्या 4 steps आपल्या डोक्यात क्लिअर असल्या पाहिजेत. Pedagogy is way more important than the technology that you use. Learning outcomes are way more important than the technology that I use. So once we are clear about the first 4, then think about the technology. मग कोणता ऍप वापरायचं, कोणती डिव्हाइस वापरायची, किंवा ऑनलाईन कुठली वेबसाईट वापरायची, हे सगळं नंतर येतं. आणि मग दरवेळी शिकवल्यानंतर वी ऑलवेज हॅव टू रिफ्लेक्ट, थिंक अबाउट व्हॉट वर्क, व्हॉट डिडंट वर्क, how can we improve, how can we change the way we teach it next time, and so on and so forth. So आपली टीचिंग प्रोसेस ही साधारणतः अशी असते किंवा अशी असली पाहिजे, म्हणजे लर्निंग आउटकम्स, टीचिंग प्रॅक्टिसेस आणि असेसमेंट्स हे एकमेकांना अलाइन्ड असले पाहिजेत, म्हणजे एकमेकांशी त्यांची जोड बांधली गेली पाहिजे, तर ती टीचिंग प्रोसेस खूप चांगली होते. मग अशी टीचिंग प्रोसेस समजा आपल्याला करायची असेल आणि जसं मी मगाशी म्हणलं तसं लर्निंग कशामुळे चांगलं होतं असं आपल्याला समजा बघायचं असेल तर तुम्हाला काय वाटतं? सो लेट्स ऍक्च्युअली टेक अ पोल. Here what I'm going to do is I'm going to talk about two scenarios. One in which there is a set of students that is learning how the blood is pumped by heart. Okay, and what they are doing is that जेव्हा ते वर्गात आले सुरुवातीला टीचरनी त्यांचे ग्रुप्स बनवले, ते ग्रुपमध्ये बसले आपापल्या. मग टीचरनी त्यांना सगळ्यांना वाचायला एक पेज दिलं ज्याच्यामध्ये आपल्या हृदयातलं ब्लड कसं पंप होतं, कुठनं कुठे जातं, असे सगळे त्याचं डिस्क्रिप्शन नीट लिहिलं होतं. आणि त्याचबरोबर त्यांना एक अशी रिकामी हार्टची डायग्राम दिलेली आणि मग त्यांना सांगितलं की हे वाचा, एकमेकांशी चर्चा करा आणि त्याच्यामध्ये एरोज काढा तुमच्या डायग्राम मध्ये की कुठनं कुठे ब्लड जातं आणि नंतर मला एक्सप्लेन करा की कसं ते ब्लड कुठनं कुठे फ्लो होतंय. हे पहिल्या वर्गात झालं. दुसऱ्या वर्गात मात्र टीचरनी त्यांना एक असं छान ॲनिमेशन दाखवलं आणि त्या ॲनिमेशन मध्ये आता मी इथे साऊंड लावत नाहीये कारण साऊंड खूप लाऊड आहे, पण ॲनिमेशन मध्ये सगळं छान एखाद्या मूवी सारखं दाखवलं होतं की ब्लड कुठनं कुठे जातं, पंपिंग कसं होतं, कशा प्रकारे अशुद्ध रक्त शुद्ध केलं जातं, ऑक्सिजन कसा हाउ डज इट गेट ऑक्सिजनेटेड, ऑल ऑफ दीज थिंग्स आर टॉट in the video. So the students watch the video very carefully. Now my question to you all is, and you can answer in the chat, which method is better? Is it the first method in which the students are sitting in groups, they are trying to discuss, they are trying to read a diagram and also trying to draw arrows, or in the second one where the students are watching an animation? So those of you who are on Zoom, can you please put in chat? Hello. So Poonam ma'am is saying that the second method is better. Anybody else would like to say something different or would like to support her? Okay, Rameshwari ma'am, I think, I don't know, ma'am or sir, they are saying that the second method is better. Anybody else who's listening and would like to contribute? Simre sir is also saying second method. Okay, anybody who feels that the first method is better? Pawan sir is saying both methods are better, but right now let's not go for both. If we have to choose, which one should I choose? Okay, so nobody thinks that the first method is better. Now Pawan sir is saying first one. So Pawan sir, why do you think the first one? Okay, Jyoti ma'am's response खूप छान आहे. She's saying that it should be discussion and the second method. So second method just on its own is not good, but it needs to be supplemented with discussion. So let me say this, that in reality, when the exam was taken for both of these groups, the first group actually scored better on the exam than the second one, right? So why is that? All of you are thinking that the animation works better than the first one, but that is not true. Okay, it will work just as effective or a little more effective if it was just picture versus animation. But remember that in the first method, the students are not only looking at the picture or reading, they are discussing, they are trying to come up with the knowledge by themselves, they are involved in learning, right? They are putting their brains in when they are actually making those arrows. They cannot blindly make those arrows. They also have to justify their choices. Why did you show this arrow going from here to here? They have to explain it to the teacher later on. So in reality, the truth is that the media in which you teach does not matter. It doesn't matter if I use animation versus videos versus just a book, or a lecture thing. But what really matters, of course, it matters a little bit, you can say, the media matters a little bit, but what mostly matters in your class is whether the students are involved in learning, whether the students have their minds on. So this is something that we always say, that the students need to have not only their hands, but their minds involved. For example, in the second method, let's imagine that the students are watching the animation, but they are thinking about something else completely. They are thinking about what did I see for, see in last week's episode for a particular series or a particular movie, or they are thinking about what to eat tomorrow for lunch, So if their minds are not involved in while watching that movie, the pedagogy is not going to be really effective. So we need to think of methods in which we can get them to be involved. They should be completely with you when they are in the class, right? Completely involved in learning while they are in class. So when this study were done, actually ह्याच्यासारखे खूप प्रयोग किंवा खूप वेगवेगळे experiments education मध्ये झाले. All of them really point to the same thing, that we have to be involved in learning for us to learn. So what are the different methods with which we learn? So if you think about it, when we listen to something, so right now, if your mind is not involved, you're probably going to only retain 5% of it. When we read, we retain 10% of it. When we watch a video, 20%. When we actually watch a demo live, something that the teacher is performing or our friend is performing, it stays with us 30% of the time. Discussing with peers is 50%, and more importantly, activity is 75, teaching peers is 90. So if I want the students to be involved and really be able to retain, I need to focus on the last three, whether the discussion is happening within each other. So it is not only important that the student should talk to me, they should also talk to each other during the class. Okay. They should be doing some kind of activity, and not just with hands. When their hands are involved, they should also do it with minds on, right? So they are not only doing an experiment in lab, but they're thinking about how this experiment is working at the same time. And of course, teaching peers, like discussing and then, coming back to you and discussing and telling you something that they have learned is extremely important for our students' learning process. So if you think about it, the first two methods that we saw, the second method was just watching a video. The student just watched a video, which was 20% retention. But the first method involved them to read, which is around 10%, discuss with peers, which was a very high learning, that was 50%, do something like with hand, they had to draw 75%, and also come back to the teacher and, justify their choices, which was closer to teaching with peers. So all of these steps really help the first one to be more effective. So that's the reason why it is not the media, it is how our students are doing that particular activity, what they're doing as they're doing it, right? So I hope the message here is clear, how we proceed. Okay. And then there are various active learning techniques or active learning strategies. So what is active learning? Some process in which a student's mind as well as their hands, or they're very active in the classroom. So there are all of these active learning techniques that have been documented, which could be very simple things like think, pair, share, or writing a small paper, a minute paper, meaning you are just writing a small, what you learned in one line or two lines. Or you could do some case studies that could be discussed in the class, or brainstorming activity, or you can do some hands-on learning, that is actually experimentation, games and simulation, role playing. All of these are various active learning techniques that have been documented that can be used in class. And if you see some of the really important ones, the complex ones that actually generate high learning outcomes are inquiry based learning. You can have experiential learning, which will be mainly problem based learning, which we'll talk about. You can have role playing, you can have active review sessions through games and simulations, which we'll also talk about in today's talk. So in my class, I need to focus on this particular spectrum here. Yeah. So I need to focus on this particular part as much as possible, so that we can have higher learning outcomes. Of course, I'm not saying that you start from there. You can start from very simple things, but slowly as we progress in our teaching, our aim is to go up this chart. Okay. Okay. So थोडंसं पुढे जाऊया आणि काही थोड्याशा स्ट्रॅटेजीज बघूया की that really help us in achieving this active learning as we were discussing. So what is active learning? First thing is that it needs to be engaging. का शिकायचं मुलांनी? First of all, उद्या तुम्हाला कोणीतरी काहीतरी शिकवायला लागलं, first question you will ask as a learner is, why should I bother about this? How is it going to help me? Is it important for my living? Is it important for my everyday universe? माझ्या जगात मला ह्याचा खरंच फायदा होणार आहे का? सो अँड इज इट एंगेजिंग? मग कदाचित त्याच्यात मला मजा येते का, किंवा रोजच्या एव्हरीडे लाईफ विषयी मला नवीन काही कळतं का? सो इट हॅज टू बी एंगेजिंग. इन सायन्सेस we should really aim for process oriented, right? We don't want to teach our students laws and theorems just to remember them. Our aim should be that our students actually learn the process of science. They need to learn how to think rather than what to think, right? So they need to know, and that is something that they will take with them as they graduate. They will learn how to think, and they can apply that same thought process to multiple other things in their life. As I said, it has to be applicable to solving everyday problem, real world problems, and inclusive. So all of these strategies, once we start applying, our classroom becomes better and better. Let's talk about the first one, engaging context. Context म्हणजे काय तर मी का शिकायचं, त्याच्यासाठी त्या स्टुडंटना त्याच्याशी रेलेव्हंट काही सापडतंय का? म्हणजे आजच्या धड्यामध्ये, सपोज टुडेज टॉक इज लॉज ऑफ इलेक्ट्रोमॅग्नेटिझम, राईट? और टुडेज टॉपिक इज लॉज ऑफ इलेक्ट्रोमॅग्नेटिझम. व्हाय शुड आय रिअली केअर अबाउट इलेक्ट्रोमॅग्नेटिझम as a student? Or today somebody is talking about biodiversity. Why should I care about biodiversity? And if the student is clear about that, they get involved in learning and their minds are on, right? So various things that we can do. First one is pop culture. Pop culture म्हणजे movies, cinemas, त्यांचे म्हणजे मुलं आज काय बघतायत, त्यांच्या डोक्यात काय आहे. आय थिंक एका सरांनी प्रश्न विचारलेला की मुलांना आजकाल वर्गातच यायचं नसतं, तर काय करता येईल त्यांना वर्गात आणायला. एक सोपं उत्तर असं देता येईल की त्यांना जे काही वाटतंय, त्यांच्या दृष्टीने काय महत्वाचं आहे आता, त्याच्याविषयी आपण काही शिकवू शकतो का? म्हणजे शिकवायचं आपल्याला फिजिक्स, केमिस्ट्री, मॅथ्स, बायो, हिस्ट्री, जिओग्राफीच आहे, पण समजा त्यांना आवडणाऱ्या एखाद्या रूपात ते आपल्याला टाकता येईल का? सो फॉर एक्झाम्पल, कित्येक मूवीज मध्ये काय काय वेगवेगळं सायन्स दिसत असतं. Can I discuss a movie in class and discuss the corresponding science? For example, in one of the series, it was actually Indian movie चं उदाहरण देते की कहाणी मूवी मध्ये तो बॉम्बे ब्लड ग्रुप आला होता आणि बरेच मुलं आमच्या इथे खूप कन्फ्युज होती की हे बॉम्बे ब्लड ग्रुप म्हणजे काय. मग ज्यावेळी आम्ही ब्लड ग्रुप्स विषयी शिकवायला सुरुवात केली, त्यावेळी आम्ही फक्त AB किंवा O ह्यांच्याविषयी न बोलता त्यावेळी सुरुवात अशी केलेली की हा तुम्ही मूवी पाहिला का, मग त्याच्यामध्ये असं असं होतं, मग हा बॉम्बे ब्लड ग्रुप म्हणजे काय, अशी सुरुवात करून त्यांना हळूहळू ब्लड ग्रुप्स विषयी शिकवलं होतं. सो वी कॅन ऑलवेज थिंक ऑफ रेलेव्हंट थिंग्स दॅट आर स्टुडंट्स आर थिंकिंग अबाउट. आपण त्यांना गोष्टी सांगू शकतो. स्टोरीज आर व्हेरी व्हेरी इंटरेस्टिंग, एस्पेशली हाऊ सायन्स प्रोग्रेस्ड, the way in which science has helped mankind. There are some really brilliant stories that we can find, and slowly we have to build our story inventory, that for this topic I will share this story, for this topic I'll share this story. For example, the story here is about a drug called thalidomide, and this is a molecule that created havoc in Europe and in some parts of Asia as well, because this molecule here is one second, let me start my pen. Yeah, so this molecule here has a chiral center, and until this molecule was used as a drug, we didn't know that chiral molecules can really have to be pure, in the sense that we can only give one enantiomer and not the other one. So as you can see, there is a chiral center there that can have different 3D geometry. So one of the enantiomer was actually curing the disease, or rather was actually helping pregnant women to cure morning sickness and other pregnancy symptoms. But the other enantiomer actually created a lot of birth defects. So many babies were born without limbs, without hands, without legs, without important body parts. And until those babies were born, we didn't know. So when I'm talking about stereochemistry in class, I always start with this particular story, so that my students are interested. Now they're curious that every drug that they take, then they think about, oh, is paracetamol, does it it's a drug that I take probably very routinely, does it have a chiral center, what about acetaminophen and all of these other things. So they will start looking at molecules for chiral centers. They will start thinking, is this molecule safe to treat, and what kind of drug studies have been done. So it's very important for us to know the stories as teachers. We can also talk about some current affairs. For example, right, just a few days ago, there was a COP26 happening in Glasgow, which talked about climate change. So how does it relate to my topic? Or we can ask them some provocative questions like, why should everyone take COVID-19 vaccine? Is it important? Tomorrow, if I decide that I don't want to take a vaccine, is it bad for me? Is it bad for my neighbors? Is it bad for, the community? So we can ask them to think and really look at current affairs, provocative questions, and also some local relevance. So this Pani Puri story is my favorite, because this is something we have tried very often. Is that in biology, we have a practical in which students actually really identify different microbes in water. For many years, the water sample was given to the students. We were giving the same water sample to everyone. The water was mainly from a pond nearby, and students were identifying the water sample, what are the different microbes in it. त्याच्यामध्ये असणारे बॅक्टेरिया वगैरे ते दरवेळी त्याच्यातलं शोधायचं. इन अ व्हेरी स्मॉल ट्विक व्हॉट वी आपण काय केलं की त्यांना सांगितलं की तुम्ही पाणी आणा, आणि कुठनं आणा, तर आपल्या कॉलेजच्या बाहेर जे पाणीपुरीवाले आहेत, भेळपुरीवाले आहेत, त्यांच्याकडनं आणा. आणि मुलांचं सगळं आउटलुकच बदलला, बिकॉज दे यूज टू ईट ॲट दॅट पर्टिक्युलर वेंडर्स पाणीपुरी ठेला एव्हरी इव्हनिंग. नाव दे वर व्हेरी क्युरियस की मी जी पाणीपुरी खातोय त्याच्यामध्ये काय काय मायक्रोब्स आहेत, त्याच्यात काय काय बॅक्टेरिया आहेत. अँड सरप्राइझिंगली इनिशियली आम्हाला स्टुडंट्सच्या मागे लागायला लागायचं की आम्हाला रिझल्ट दाखवा, चला हा एक्सपेरिमेंट करा, सगळे आलेत ना एक्सपेरिमेंटला. फॉर दिस पर्टिक्युलर एक्सपेरिमेंट the students were so involved, because it was something related to their lives. They were asking us, okay, when are we doing this? I really want to check this particular vendor versus that vendor. I think he is cleaner. Will he have, higher bacterial load and other things? So it was very much related to their life. And that's where we can get our students to be involved. That's where we can get our students to really participate in class. So जो सरांनी प्रश्न विचारलेला की मुलांना वर्गात कसं टिकवून ठेवायचं, तर सिलेबस तोच राहू दे. आम्ही मायक्रोबियल लोडच शिकवलं, फक्त त्याच्यामध्ये कशा पद्धतीने शिकवायचं किंवा काय सामग्री वापरून शिकवायचं, what material should be used is now in a very different format. Okay. Where to look for stories. So ही स्लाइड तुम्ही नंतर बघू शकता. खूप छान ह्याच्यामध्ये चॅनल्स आहेत, वेगवेगळे एज्युकेशन जर्नल्स मध्ये आर्टिकल्स असतात की ज्याच्यामध्ये हा टॉपिक शिकवताना या स्टोरीज तुम्ही सांगू शकता वर्गात. अशा पद्धतीने ते आर्टिकल्स लिहिलेले असतात. तुम्ही नक्की बघा. You please go through all of these channels. And if you have some other resource for science stories, please let us know. We would love to add it to the bank. Some of the other methods, making models is something that all of us use. We also use demonstrations in class. So I'm not going to talk about these two, but both of these methods, there has been enough work already done. You can see the YouTube channels of all of these amazing people, in different fields of sciences that actually perform things in class. They actually do experiments in class. And it is one of the best ways to engage your students. So इथे वॉल्टर ल्युइनचा जो MITचा चॅनल आहे, हा मी नक्की सगळ्यांना रेकमेंड करीन बघा, कारण ऍक्च्युली वर्गातली लेक्चर्स त्यांनी त्याच्यामध्ये दाखवलेली आहेत, किंवा HC वर्मांची स्वतःची ते कसे शिकवतात, वर्गात कोणकोणते डेमोज घेतात, हे तुम्हाला डायरेक्टली बघता येईल. ओके, सो आय विल नॉट टॉक मच अबाउट इट बिकॉज वी हॅव अदर इम्पॉर्टंट थिंग्स टू टॉक. Let us go ahead. Enquiry based learning. So one of the questions that I had asked, and many people said that they teach with enquiry. So can somebody explain it to me? What do you mean by enquiry? Somebody who can unmute themselves and hello. So when you said that you teach very often with enquiry, I want to know, आणि म्हणूनच मी चॅट मध्ये पण टाकलेलं काल की if you can share some examples of how you're using enquiry. What is enquiry really? Hello. कोणी सांगू शकेल? रुपाली मॅम सांगतात बहुतेक. रुपाली मॅमनी अनम्यूट केलंय.
Ma'am, in inquiry based learning, we can ask questions. Again, if they are having some previous knowledge about the content, we can ask about that previous knowledge. In such a way, we can justify the inquiry based learning.
Okay, so one of them is asking questions, as you are saying. So yes ma'am. So what Rupali ma'am is actually discussing is the questioning method of teaching. Let me be clear that this is different from enquiry. In enquiry, the teacher can ask the question, but the student really comes up with methods to solve the question. Very often it is good if the student themselves asks a question. सो थोडंसं बघूया कशी करता येते एन्क्वायरी. सो एन्क्वायरी म्हणजे काय, तर आपण लॅबमध्ये जो रिसर्च करतो, व्हेरी ऑफन वी ऑब्झर्व समथिंग, वी कम अप विथ क्वेश्चन्स, देन वी थिंक ऑफ अ हायपोथेसिस दॅट व्हॉट एव्हर वी सॉ, वाय डिड वी सी इट, और असं का झालं असेल, अँड देन वी formulate a hypothesis. We come up with experiments to really justify our hypothesis. We perform those experiments. Then we look at the data, then we do the data collection and we analyze it, and then we say, okay, माझा hypothesis चुकीचा होता का बरोबर होता. ही एक जनरल प्रोसेस एन्क्वायरीची सगळे सायंटिस्ट फॉलो करत असतात. कुठल्याही सायन्स मध्ये जा, इवन नॉन सायन्स सब्जेक्ट्स मध्ये. सो फॉर एक्झाम्पल इन सोशल सायन्सेस or in various other streams, for example in law, enquiry process is very important. Ethical enquiries are done in laws. or you can do, if you're doing history or geography, in geography you're doing various kinds of inquiries, like why did this rock formation happen this way, what could have happened. So you're trying to formulate a hypothesis based on what you're seeing as an observation, right? आणि ही एन्क्वायरी प्रोसेस गरजेची का आहे, मुलांनी हे करणं गरजेचं का आहे, तर वी आर रिमेंबर दॅट इन ऑल अदर प्रोफेशन्स, आता तुम्ही इथे बघू शकता की इथे पहिला जो फोटो आहे तो कोणाचा आहे, डू यू नो दिस पर्सन?
इज इट तेंडुलकर?
इट्स तेंडुलकर. आणि त्यांचे सर त्यांना काय करायला, म्हणजे आचरेकर सर काय करायला लावतात तेंडुलकरला? How is he learning cricket?
Correcting his stance.
So what Achrekar sir is doing is actually, you know, working on his skills. म्हणजे सचिन क्रिकेट कसं खेळायचं हे पुस्तकं वाचून नाही शिकला. He actually went to the field, he batted for hours together and gained that skill of, you know, that straight drive, amazing straight drive. He had to practice for hours, right? He was practicing it. Same thing here. Who are these two? So Zakir Hussain and Allah Rakha, again they are practicing. जे तबला वाजवायला शिकले ते फक्त पाठ्यपुस्तकातनं नाही तर, you know, hours of practice. सेम थिंग एखादा शेतकरी ज्यावेळी शेतात काम कसं करायचं ते आपल्या मुलाला शिकवत असतो, he actually takes the kid to the field. The kid is learning on the job, right? कथ्थक शिकवताना, नाच शिकवताना तुम्ही नुसतं लिहून वाचून ते शिकवू नाही शकत. मग तसंच सायन्स ज्यावेळी आपण शिकवतो तर त्यावेळी आपण मुलांना एवढी सगळी पुस्तकं वाचायला का लावतो, किंवा त्यांना वर्गात बसून फक्त सायन्स कसं शिकवता येईल. We have to work with them such that they think like scientists, they start thinking like scientists, they start doing the same processes that scientists are doing. मग सायंटिस्ट काय करतायत, तर सायंटिस्ट स्वतःचे प्रयोग स्वतः तयार करतात. सायंटिस्ट एखादा ऑब्झर्वेशन घेतात, त्याच्यावरनं हायपोथेसिस करतात. जसं मी मगाशी पूर्ण प्रोसेस सांगितली ती सायंटिस्ट हे स्वतः करतायत, अँड दॅट इज व्हॉट इज मोर इम्पॉर्टंट, right? So all of these things we have to get our students to do in class, instead of them just, you know, listening to lectures or you know, solving problems even in the notebook. So for example, माझा जॉब आहे शिकवायचं कसं हे टीचर्सना शिकवणं. आता तुम्ही समजा आयसरला आला असाल तर what I will make everyone do is I'll actually make you teach. And then I will correct you, or I will give you suggestions that this is how, where we could have improved, this is where we could do something different. So the idea here is that you need to actually practice what you're teaching. You're actually getting the students to perform the tests, perform the things that you're asking them to do, right? So that is inquiry. Okay. Let us go ahead and let us see how we can do it in science classroom now. Okay, एक छोटंसं एक्झाम्पल घेऊया. आपण थोडेसे वेळेच्या मागे होत तर मी खूप नाही याच्यावरती वेळ घालवणार, but I want everyone to participate so that we can cover more things. Okay, so असं समजा मी विद्यार्थ्यांना एक छोटंसं चित्र दाखवलं. If I show them this drawing and if I ask them that these are the dinosaur tracks that have been recovered and recently uncovered by some scientist. So what are the different hypotheses that you can make? कोणी सांगू शकेल? What questions can you ask looking at this figure? Can you share some questions? You can just unmute yourself and talk to me.
How many types of dinosaurs are there?
Okay, so first of all, how many types of dinosaurs? So I see two different prints. Does it mean that they are by two different dinosaurs, right? What else? How many questions can we come up with? Different questions.
Are they going in same direction?
So are they going in same direction? Okay, so त्यांच्या footprints वरनं can we determine the direction of their walk? What else?
To find the age of the dinosaur.
Okay, can I figure out the age of this dinosaur based on the footprint? Okay, what else? There are many questions that we can actually ask looking at this one figure. So maybe 2-3 more questions and then we'll go ahead.
The size of their foot.
Okay, so based on the footprint, can we predict their size?
Yes.
Oh, okay, yes, wonderful question, ma'am. What
the
else?
tracks on the right hand, the tracks on the right hand side, there's a difference in the distance of the foot.
Wonderful observation, sir. So there is a gap here. Why is there a gap, right? And on this side, there is no gap. So what is this dinosaur doing differently, right? So on this side, you have that gap. Okay. So all of these questions, remember, you are coming up with, right? So that is the first step for scientists, is to look at an observation and come up with hypothesis or come up with questions की हे असं का झालं असेल आणि मग हे मी प्रूव्ह करू शकतो का, मला वाटतं असं असं झालं असेल तर ते मी प्रूव्ह करू शकतो का, is the question, right? So let us go ahead and we can think of various questions की size, nature, तुम्ही काय काय याच्यापैकी सांगितले, tracks सेम टाइमला झालेत का एक डायनासॉर आधी आलेला दुसरा डायनासॉर नंतर आलेला, किती डायनासॉर्स आले ह्याच्यात, कॅन सॉइल कशी होती त्यावेळेचं ऍटमॉस्फिअर कसं होतं ह्याच्याविषयी मला काही कल्पना येईल का, त्यांच्या स्पीड बद्दल काही कळेल का. सो ऑल ऑफ दीज थिंग्स वी कॅन आस्क. वी कॅन ऑफकोर्स गो अहेड अँड टेल देम दॅट नेक्स्ट पुढचं ज्यावेळी त्या सायंटिस्टनी डिगिंग केलं त्यावेळी त्यांना अजून थोडेसे जास्त प्रिंट्स मिळाले. आता काही फरक वाटतोय का किंवा आता काही वेगळे प्रश्न पडतायत का हे बघून. नाउ वी हॅव अ additional information. Now we have gained one more set of information from our experiment. Let's say the experiment was digging. Now that we have more data, can we come up with more questions? किंवा मगाचे काही प्रश्न आपल्याला चेंज करायचे का.
Are they in a group?
सो आर दे इन अ ग्रुप. ओके, म्हणजे ते दोन डायनासॉर समजा मी म्हणलं जात होते तर ते एकत्र भेटले का, राईट? और आर देअर मोर डायनासॉर्स कमिंग अप अँड गॅदरिंग इन अ ग्रुप. व्हॉट एल्स? अजून थोडे प्रश्न सुचतायत आपल्याला.
Are they at the same time in the same place?
आर दे ऍट द सेम टाइम म्हणजे त्यांनी एकत्र येऊन काही केलं का. परफेक्ट. एनिथिंग एल्स? Anything else? Come on, we can think of more questions, right? We are all science teachers. Or
some questions are in chat box.
Chat box, okay. एक मिनिट मी वाचते. कोणी तर हा, सो बिराडे सर म्हणतात त्यांची भांडणं चालू आहेत का किंवा त्यांचे फाईट चालू आहे का तिथे. टाइप ऑफ इंटरॅक्शन, काय प्रकारची इंटरॅक्शन झाली, म्हणजे ते भांडले का एकमेकांना प्रेमाने भेटले का काय झालं एक्झॅक्टली, का ते खाण्यासाठी भांडले एकमेकांशी, म्हणजे एकमेकांशी भांडले नाहीत पण खाली काहीतरी जेवण होतं ते एकत्र खायला भांडले. सो ऑल ऑफ दीज आर very relevant questions, and remember these are questions coming from you guys. I'm not telling you the questions, but I'm getting you to ask the questions, so you can also think of some other questions like this. We can even go further and then we say पुढच्या वर्षी अजून थोडं डिगिंग झालं आणि आता अजून थोडा एव्हिडन्स मिळाला, आता काय वाटतंय. आता what kind of questions come to your mind, or what kind of you can think of previous questions that you want to eliminate or add. Additional information आली आता आपल्याकडे. सो काय फरक पडेल का आपल्या आधीच्या हायपोथेसिस वरती.
They went toward the same direction.
They both, okay, दोघही सेम डिरेक्शनला गेले असं झालं का. What else could be a possibility? अजून काय झालं असेल? एक मोठा डायनासॉर वाटतोय फुटप्रिंट्स वरनं आणि एक छोटा वाटतोय. तर मोठा आणि छोटा यांची काय इंटरॅक्शन झाली असेल?
मोठे डायनासोर एक साइडला जात आहे आणि छोटे डायनासोर तिथेच राहिले.
असंही होऊ शकेल की मोठा डायनासॉर पुढे गेला, छोटा डायनासॉर तिथेच राहिला. पण मग त्याचे फुटप्रिंट्स नंतर कुठे गेले? त्याचे फुटप्रिंट्स नंतर कुठेतरी दिसले पाहिजेत ना, परत येताना तरी, नाही तर पुढे जाताना तरी दिसले पाहिजेत. मग काय झालं असेल छोट्या डायनासॉरचं?
The bigger one superimpose the smaller one.
सॉरी मॅम, कॅन यू रिपीट?
The bigger one is superimpose the smaller one.
ओके, सो मोठ्या डायनासॉरच्याच फुटप्रिंट्स वरती छोट्या डायनासॉरचे फुटप्रिंट्स असतील. इज इट लाईकली दो? अगदी तसेच्या तशा फुटप्रिंट्स वरनं त्यांनी चालत जाणं म्हणजे पॉसिबल वाटतंय
That
का?
is not the meaning.
देन
Overcome.
ओके, सो मोठ्या डायनासॉर कदाचित छोट्या डायनासॉरला खाल्लं.
तिथे दोन लेवल आहे मॅडम. पहिली लेवल दोन्ही डायनासोरनी पास केली आहे, पण सेकंड लेवल जी आहे ती फक्त मोठ्या डायनासोरनी पास केली.
म्हणजे काय लेवल काय? हे एकाच ग्राउंड वरच आहे.
दोन लाईन्स आहेत. देयर इज 2 लाईन्स मॅम.
ते आपण मी आता ज्या पद्धतीने फोटो दाखवले त्यानुसार आहेत ते सर. पहिल्या वर्षी हा एव्हिडन्स मिळाला, दुसऱ्या वर्षी हा, तिसऱ्या वर्षी हा. सो लाईन्स म्हणजे लेवल्स नाही आहेत त्या एकाच जमिनीवरती. हे मला एकाच फ्लॅट जमिनीवरती एवढे सगळे मला फुटप्रिंट्स मिळालेत. फक्त ते मिळत हळूहळू गेलेत.
May be died, smaller one.
The smaller one may be died. Now there are various possibilities that the bigger one ate the smaller one, or what else is the possibility?
There may be breeding between two species and formation of new species.
तर एकाच म्हणजे फॉर्मेशन ऑफ न्यू स्पीशीज ला बरीच वर्ष लागतात ना. यू हॅव लाईक many years should pass between one species and the next one. So is it possible? Is that hypothesis probable?
It also indicates their capacity or limitation.
Of what?
Hello, madam.
Okay, so one possibility is that the bigger one ate the smaller one. What other possibilities are there?
One bigger one carry the smaller
possible one. Very good. So that the bigger one is, let's say, the mother and the smaller one is the baby. They both met. They ate something. The baby climbed on the back of the mother and they went. Right. So that's a possibility. What other possibility? There are multiple possibilities. See, just with 3 pictures, we can get people to think. This is what our aim is, right? We want the students to start thinking, right? They need to learn how to think rather than what to think. That is the whole aim. So let me share one more experiment with you. So observation करणं आणि थिंकिंग प्रोसेस आपल्याला मुलांची सुरू करणं हे आपलं एम आहे इन एन्क्वायरी बेस्ड. अजून एक छोटासा एक्सपेरिमेंट दाखवते. अगदी सिंपल केमिस्ट्रीचा एक्सपेरिमेंट आहे, ज्याच्यामध्ये पाणी घेतलंय पहिल्यांदा पेट्री डिश मध्ये आणि दोन्ही साईडला 2 सॉल्ट्स टाकली आहेत. एका साईडला KI टाकलंय and the other side has lead nitrate. Now as both of these salts interact or they diffuse in the water, slowly they are going to form a reaction front. So here what I'm seeing is that reaction happening between the 2 salts, right? The yellow formation of precipitate is really a reaction happening between the 2, right? So slowly if I let it progress, I will see that there is reaction happening, right? So, and if I shake it, later on the yellow color of lead iodide will form everywhere, right? And we do these kind of reactions. We do all kinds of reactions and tests in lab very often. Very often the questions that we ask to our students are also very standard. Ki lead nitrate आणि potassium iodide ची reaction लिहा, balanced chemical reaction लिहा, आणि मुलांनी ती बरोबर लिहिली तर आपण त्यांना मार्क देतो, नाही बरोबर लिहिली तर त्यांचे मार्क कट होतात, राईट? दॅट इज वेअर मोस्ट ऑफ अस आर ऍक्च्युअली asking questions to our students regarding a chemical reaction. नाउ दिस सेम एक्सपेरिमेंट इफ आय आस्क की ती जी येलो लाईन मध्ये बनत होती मगाशी आपल्याला दिसलेली, त्या येलो लाईनची पोझिशन कोणकोणत्या फॅक्टर्समुळे अफेक्ट होईल? काय काय फॅक्टर्स वाटतात?
सॉल्युबिलिटी.
सॉल्युबिलिटी, ओके. सो सॉल्ट कोणतं घेतलं आणि त्याची सॉल्युबिलिटी काय आहे?
रेट ऑफ डिफ्युजन.
रेट ऑफ डिफ्युजन. मग रेट ऑफ डिफ्युजन कोणकोणत्या फॅक्टर्स वरती अवलंबून असतो?
ॲटॉमिक वेट.
ॲटॉमिक वेट वरती, ओके. म्हणजे अगेन सॉल्युबिलिटी ऑर द सॉल्ट बेसिकली, की सॉल्ट बदललं तर त्याची पोझिशन चेंज होईल का? अजून काही? व्हॉट अदर फॅक्टर शुड अफेक्ट द पोझिशन ऑफ दॅट? येलो लाईन मध्ये फॉर्म होतीये का एका बाजूला फॉर्म होतीये, डाव्या बाजूला फॉर्म होतीये का उजव्या बाजूला फॉर्म होतीये? काय फॅक्टर्स असतील?
कोलिजन्स मॅम, इंटरॅक्शन.
हा, मग म्हणजे काय फॅक्टर काय आहे त्याच्यात? कोलिजन मध्ये फॅक्टर एक्झॅक्टली कोणता आहे?
टेम्परेचर.
टेम्परेचर इज वन ऑफ द फॅक्टर्स. व्हेरी गुड. सो टेम्परेचर मी कदाचित त्याची पोझिशन बदलेल का मी वेगवेगळ्या टेम्परेचरचं पाणी घेतलं तर? अजून कशाने पोझिशन बदलू शकेल?
कॉन्सन्ट्रेशन.
कॉन्सन्ट्रेशन, व्हेरी गुड. अजून काही? अजून काही वेगवेगळे अजून बरेच सारे आपल्याला पॅरामीटर सुचू शकतात. म्हणजे मी पाण्याऐवजी दुसरं कुठलं लिक्विड घेतलं तर त्याची पोझिशन बदलेल का? किंवा पाण्यामध्ये ऑलरेडी डिफ्यूज सॉल्ट्स असतील तर त्याची पोझिशन बदलेल का? टेम्परेचर, वेगवेगळ्या टेम्परेचरचं पाणी घेतलं आणि ऑल ऑफ दीज फॅक्टर्स. डेन्सिटी कशाची सर?
वॉटर.
हा, मग वॉटरची डेन्सिटी आपण त्याच्यात वेगवेगळ्या गोष्टी मिसळून बदलू शकतो. सो डिपेंडिंग ऑन दॅट त्याची पोझिशन बदलेल का? सो ऑल ऑफ दीज फॅक्टर्स रिअली आर गिवन बाय द स्टुडंट्स. राईट नाउ ऑल्सो यू आर गिविंग मी द फॅक्टर्स. आय एम नॉट टेलिंग यू द फॅक्टर्स, बट all of you are coming one by one with one factor that you think could affect the position of the reaction front. And then if I ask the question that can we design an experiment? आता तुम्ही सर मगाशी म्हणत होते टेम्परेचर आहे, मग मी त्यांना म्हणेन तुम्ही एक असा एक्सपेरिमेंट डिझाईन करू शकता का की तुम्हाला कळेल की टेम्परेचरचा रिएक्शन फ्रंटच्या पोझिशन वरती काय परिणाम होतो? कॅन यू डिझाईन अन एक्सपेरिमेंट टू टेस्ट द इफेक्ट ऑफ टेम्परेचर on the position of reaction front?
Yes, ma'am.
Right? So, sir, काय कराल मग तुम्ही त्याच्यात?
The same experiment carried out at different temperature.
Okay, so what is your independent variable here? What is your dependent variable? काय तुम्ही measure कराल? कसं measure कराल?
Okay, precipitation formation as per temperature.
Okay, so you will vary temperature, so that is your independent variable, but the reaction front is your dependent variable. So you will try to मग तुम्हाला खाली ग्राफ पेपर ठेवायला लागेल आणि मग ते मार्क करायला लागेल कुठे एक्झॅक्टली येत आहे. म्हणजे मेथडॉलॉजीचा विचार तुम्ही करून मला सांगाल, राईट? मी नाही सांगणार आहे ऍज अ टीचर, बट ऍज अ स्टुडंट माय स्टुडंट विल टेल मी की मी असा एक्सपेरिमेंट डिझाईन करीन. मग ते करताना मला काही कंट्रोल्स ठेवायला लागतील की मे बी आय विल हॅव टू कीप द कॉन्सन्ट्रेशन ऑफ बोथ द सॉल्ट्स द सेम. आय विल हॅव टू कीप द अमाउंट ऑफ वॉटर द सेम. आय विल हॅव टू कीप let's say the type of water, whether I'm using hard water, soft water, that will have to be the same. Or DI water, I'll have to keep the pH the same. So the student is thinking about how to design an experiment. The student is not told that your aim is this, your procedure is this, you should do XYZ and you'll get your answer. But the student is involved in designing that experiment. And he or she has slowly started thinking as a scientist. कारण एखाद्या सायंटिस्टला जेव्हा एखादा एक्सपेरिमेंट डिझाईन करायचं असतो त्यावेळी तो काय करतो? तो ह्याच सगळ्या गोष्टींचा विचार करतो. मग माझ्या स्टुडंटला मी हा अनुभव देऊ शकतो का वर्गात, किंवा देऊ शकते का, इज व्हॉट ऍज अ टीचर आय नीड टू थिंक. सो देर आर व्हेरियस टाइप्स ऑफ एन्क्वायरीज की अगदी सुरुवातीला सोप्या एन्क्वायरी, स्ट्रक्चर्ड एन्क्वायरी मुलांना देता येते की ज्याच्यामध्ये सगळ्या अख्खा वर्ग एक प्रकारची एन्क्वायरी करतोय. टीचर मध्ये मध्ये गायडन्स द्यायला आहे. टीचरनी बरीच मेथड मदत केलेली आहे की कदाचित टीचर एम देईल मुलांना पण मेथड सांगणार नाही, किंवा एम आणि मेथड सांगेल, पण पुढचा अनालिसिस कसा करायचा ते सांगणार नाही, आणि ते मुलांनी करायचंय. कंट्रोल्ड मध्ये टीचरनी एक टॉपिक चूज केलाय आणि मुलांना काही रिसोर्सेस दिलेत, पण मुलांनी त्यांचा प्रश्न स्वतः डिझाईन करायचा आहे. सो आता आपण जी केली ती थोडीफार कंट्रोल्ड एन्क्वायरी होती, की तुम्हाला माहिती होतं की ह्या रिॲक्शनचा विचार करायचा आहे, तुम्हाला माहिती होतं की ह्या प्रश्नाचा विचार करायचा आहे, डिफ्युजन कसं होतं ह्याचा विचार करायचा आहे. सो इट वॉज अ कंट्रोल्ड. देन यू कॅन ऑल्सो डू सम काइंड ऑफ गाइडेड एन्क्वायरी, ज्याच्यामध्ये मुलं आता स्वतः थोडं जास्त एक्सप्लोअर करू शकतात. मग कदाचित त्याच्यात ते स्वतः प्रश्न तयार करू शकतात आणि स्टुडंट स्वतः त्यांची प्रोसेस ठरवू शकतात की मी अशा पद्धतीने हा प्रश्न सोडवीन. आणि ऑफकोर्स इन ऍक्च्युअल रिसर्च दिस इज समथिंग व्हॉट हॅपन्स इज द फ्री एन्क्वायरी, की मुलं स्वतःच ठरवतात काय करायचं, आणि किंवा सायंटिस्ट स्वतःच ठरवतायत कुठले प्रश्न सोडवायचे, कसे सोडवायचे, त्याच्यासाठी मेथड्स कोणत्या वापरायच्या. ऑल ऑफ दीज थिंग्स आर डन बाय द स्टुडंट्स. सो ऑल ऑफ दीज types of inquiry, and you can start very small in class. We don't need to start big. We can start with very structured inquiry, but slowly giving the students the freedom to think like scientists. Slowly we have to move from structured to free is the idea. And very often in undergraduate classrooms as well, free inquiry is very difficult. Even if we do the first three, if we go from here to here, we should be extremely happy. It is very difficult to do it in every class. Even if I do, let's say 2 or 3 classes like this, wherein the students are in charge of their own learning, I should be very happy as a teacher. Okay. So it is difficult to do inquiry very often or all the time, because it involves a good amount of interaction between student teacher. There is enough freedom given to the student, and there is a lot of overlap that happens such that the knowledge gets created. So that was about inquiry based learning. So as a learner, जर का माझ्या वर्गातली मुलं हे असं असा एखादा एक्सपेरिमेंट करत असतील, सो ऍज अ लर्नर त्यांचे जे वर्ब्स असतात किंवा जे ते वापरतात डिस्क्राईब करायला काय झालं वर्गात, तर ते स्वतः त्यांच्यामध्ये तो आय आला पाहिजे. आय फॉर एन्क्वायरी, आय फॉर द स्टुडंट ऑल्सो. That the student says ki me vichar kela, I noticed something, I asked questions, I planned an investigation, I planned the research or the experiment, I recorded the data, I discovered something from the data, I thought about the experiment or the data, analyzed it, then I tried to justify my hypothesis, and then I reflected on the whole thing. If the hypothesis didn't work, I again went back to wondering where did my experiment fail, why did it fail, and so on and so forth. So this inquiry learning cycle is very much important that it happens in our class. So Zarka, if I say that I am teaching with inquiry based learning, my students should be using these verbs and not the verbs like की टीचरनी सांगितलं किंवा माझ्या सरांनी सांगितलं असं असं कर, किंवा त्यांनी अशी अशी प्रोसिजर दिली एक्सपेरिमेंटची आणि मी तसा प्रोसिजरनी केलं, आणि मग त्यांनी सांगितलं की असा ग्राफ ड्रॉ कर म्हणून मी असा ग्राफ ड्रॉ केला. हे नाही झालं पाहिजे. बट वी हॅव टू गेट देम टू थिंक की आता समजा आपण हा एक्सपेरिमेंट केलाय, ग्राफ काय ड्रॉ करूया, काय करता येईल, तुला का असं वाटतंय, वाय शुड आय प्लॉट let's say pressure versus volume, should I plot del P versus del V. So all of these things we have to ask them and think about it. प्रॉब्लेम बेस्ड लर्निंग करता येतं. प्रॉब्लेम बेस्ड लर्निंग म्हणजे वर्गात प्रॉब्लेम सोडवणं नव्हे, तर मुलांना एक प्रॉब्लेम देणं, की आता इथे मी फिजिक्स, केमिस्ट्री, मॅथ्स, बायोचे काही लिहिलेत प्रॉब्लेम्स, की मुलांनी मॅथमॅटिक्स मध्ये ज्यावेळी त्यांना ऑप्टिमायझेशन शिकायचं असतं त्यावेळी कदाचित त्यांना असा प्रॉब्लेम देता येईल की आपल्या शहरात आपल्याला पिझ्झा डिलिव्हरीचे लोकेशन्स काढायचे. आपण समजा पिझ्झा शॉप ओनर आहोत आणि इफ आय वॉन्ट टू सेटअप पिझ्झा stores in my city such that the pizza can be delivered within 30 minutes to any location, how many shops should I set up, how many and where should I set up? So now the math students are learning to apply the mathematics that they are learning. Or for physics students, we can ask that as a chief engineer, you are told to you have developed an electric car. Now what you need to do is figure out the range of this driving range of the electric car. This is your battery. How much will it be able to drive on a leveled surface? How much will it be able to drive in an inclined road? So you're actually posing them with real world problems. In chemistry, for example, this is something that we routinely do in class, is that initially we are talking about all these titrations: iodometry, acid base, spectrophotometry. It's not a titration, but it's a method. DCP-IP, all of these things are different ways to estimate, let's say, ascorbic acid. Now we ask them that ascorbic acid is present in all of these different samples. They could be chewable tablets, they could be Glucon-D, that could be pure orange juice, pure ascorbic acid. Which titration will work better for which method or for which sample? So now they have to think about how many titrations they will do, and they will have to do the titrations. They will have to figure out the accuracy, so on and so forth. So it is possible to do problem-based learning, especially for higher classes. But when problem-based learning is happening, what we actually do is, we as a teacher do not tell the direct answer to the students. Remember, the student needs to learn problem solving. So if I don't give that student opportunity to learn, how will they really learn, So they are made to sit in groups. They are made to think about the strategy. What strategy will you use? How will you approach the problem? Why you are approaching the problem in this manner? Is there any other way that you can approach? So these are the questions that I ask the students, but I will not give them the answers right away, because then they will not be able to learn problem solving. So problem-based learning, when we say, we are giving them an opportunity to learn the problem solving skills. So असं समजा होत असेल, so can you think about some characteristics of PBL? की काय काय characteristics असतात? So students ने काय केलं वर्गात? Can you think of what did the students do? If let's say that the students were trying to solve that car problem, की त्यांना इलेक्ट्रिक कार ची बॅटरी माहिती आहे आणि त्यांना आता ती रेंज कॅल्क्युलेट करायची आहे फुल चार्ज वरती, तर त्यांनी काय केलं असेल? कोणी फिजिक्सचे टीचर्स आहेत का? How should I approach this problem? What were the students doing? कोणी सांगू शकेल?
काय क्वेश्चन आहे मॅम?
की समजा असं प्रॉब्लेम बेस्ड लर्निंग मुलं करत असतील वर्गात, की त्यांना मी आता समजा सांगितलं की तुम्हाला ही इलेक्ट्रिक कार ची तुम्हाला बॅटरी तुमच्याकडे आहे, तर ही कार किती किलोमीटर जाऊ शकेल हे आपल्याला आता फाइंड आउट करायचंय. तर मुलांनी काय केलं असेल? मुलं काय करतायत त्याच्यात? ग्रुपमध्ये बसून ते सॉल्व्ह करतायत, पण कशा पद्धतीने सॉल्व्ह करतायत? कॅरेक्टरिस्टिक्स काय असतील त्यांच्या प्रॉब्लेम सॉल्व्हिंगच्या?
बॅटरी कॅपॅसिटी वरती डिस्कशन करतील मॅडम.
हा, ते डिस्कस करतील. फर्स्ट ऑफ ऑल की कॅपॅसिटी म्हणजे बॅटरीची कॅपॅसिटी म्हणजे काय ह्याच्याविषयी डिस्कशन करतील. अजून काही
कुठले कंपोनेंट त्याच्यामध्ये वापरलेले आहे आणि रिएक्शन व्हायला किती वेळ लागेल, डिकम्पोज व्हायला किती वेळ लागेल.
बरोबर. सो व्हॉट द स्टुडंट्स आर डुईंग इज दे आर कोलॅबरेटिंग विथ ईच अदर. ते एकमेकांशी बोलून ठरवतायत. दे आर नॉट ओनली independently doing it, they are interdependent regarding solving the problem. The problem is very context driven, की रोजच्या आयुष्यात असणारा प्रॉब्लेम दिलेला आहे. इट इज स्टुडंट सेंटर्ड, म्हणजे प्रत्येक ग्रुपची कदाचित मेथडॉलॉजी वेगळी असेल सॉल्व्ह करण्याची, किंवा प्रत्येक ग्रुपची थॉट प्रोसेस वेगवेगळी असेल. सो त्यांनी स्वतः विचार केलेला आहे. स्टुडंट सेंटर्ड आहे आणि सेल्फ डिरेक्टेड आहे. राईट. प्रॉब्लेम कसे होते? तर प्रॉब्लेम असे चूज केलेले की ज्याच्यामध्ये मल्टिपल पॉसिबल सोल्युशन्स आहेत, एकच नाहीये. म्हणजे आता एक उदाहरण देते की आता आम्ही आयसर मध्ये असा प्रॉब्लेम देऊन बघितला की आपल्याला 1000 झाडं लावायची आहेत, कोणती झाडं लावली पाहिजेत. किती मोठा प्रॉब्लेम आहे ना. आणि हा आपण रोज म्हणजे रोजच्या आयुष्यातला प्रॉब्लेम आहे, कारण आता आपल्याला झाडं लावायची गरज आहे टू कॉम्बॅट क्लायमेट चेंज. मग कोणती झाडं लावली पाहिजेत, हाऊ विल यू गो अबाउट दिस प्रॉब्लेम. सो द स्टुडंट्स नाव हॅव टू थिंक व्हॉट आर द पॅरामीटर्स, किंवा पाणी किती लागेल, जमीन किती लागेल, किंवा हे इन्व्हेसिव्ह प्लांट स्पीशीज आहेत का, नेटिव्ह प्लांट स्पीशीज आहेत का, आपल्या इकडे असणाऱ्या बायोडायव्हर्सिटीला त्यांनी काय काय इफेक्ट होईल. सो अँड एव्हरी ग्रुप विल कम अप विथ डिफरंट सोल्युशन्स, कारण प्रत्येकाने त्या प्रॉब्लेमचा केलेला विचार हा वेगवेगळा असेल. आणि ते एक व्हेइकल आहे. म्हणजे मला आता समजा बायोडायव्हर्सिटी आणि रिलेटेड इश्यूज शिकवायचे तर मी कदाचित हा प्रॉब्लेम वापरू शकेन. सो प्रॉब्लेम्स आर नॉट एक्स्ट्रीमली ऑथेंटिक इन द सेन्स दॅट दे मे नॉट बी सॉल्वेबल बाय स्टुडंट्स. कदाचित स्टुडंट्सना नाही ठरवता येणार की कुठे कुठे पिझ्झा आउटलेट डिलिव्हरी काढायची, मगाचा जो प्रॉब्लेम होता. बट दे विल हेल्प द स्टुडंट्स टू थिंक, दे विल हेल्प द स्टुडंट्स टू लर्न हाऊ टू अप्रोच अ प्रॉब्लेम. And as a teacher, my role is only to facilitate, only to ask them questions and see if they are really progressing in their learning. So असं काही आपल्या वर्गात होतं का की ज्याच्यात मुलं बसली आहेत आपापली and they are trying to solve a problem together, an authentic problem that they will see in real life. त्याच्याच बरोबर मी म्हणलेलं तसं काही काही मुलांना घरी प्रयोग करून बघायला देता येतात की ज्याच्यामुळे त्यांना इंटरेस्ट वाढू शकतो. तर त्याच्यासाठी ह्या 2 वेबसाईट्स आहेत, अरविंद गुप्ता टॉईज आणि आयसर पुण्याच्या. तुम्ही नक्की बघू शकता. ह्याच्यावरती जाऊन खूप छोटे छोटे डेमॉन्स्ट्रेशन्स आणि एक्सपेरिमेंट्स मुलं घरी कंपाईल करू शकतात त्याच्यावरती डेटा, आणि तुम्हाला आणून देऊ शकतात, आणि मग वर्गात त्याच्यावरती चर्चा होऊ शकते. सो फॉर एक्झाम्पल, we were doing a class on sustainability and biodiversity. We asked students to download these apps. These are free apps: BirdNet, PlantNet, InsectNet. And what we asked students to do is, तुम्ही तुमच्या आजूबाजूला असणाऱ्या झाडांचे फोटो काढा, कुठकुठली झाडं आपल्या आजूबाजूला आहेत, तुमच्या आजूबाजूला असणाऱ्या बर्ड्सचा आवाज ऐका आणि कोणकोणते बर्ड्स आपल्या आजूबाजूला आहेत. And then let them post it on anywhere. So they could post it on Google link, they could post it on Padlet. So this is one of the really nice way. So this is नाशिकच्या स्टुडंट्सचा आम्ही केलेलं की त्यांनी त्यांच्या आजूबाजूला दिसणाऱ्या सगळ्या, they tried to come up with as many trees around them that they can see. They tried to come up with various insects that they saw. Now when they come to class, we'll discuss biodiversity with them, but they are already involved in learning because they have contributed to the data. They are interested in that discussion now because they have some basis formed. So we can easily do this in our classroom. अजून एक खूप छान रिसोर्स आहे हा ऑर्डिनो सायन्स जर्नल. अगेन इट्स अन ॲप that you can download. Ask your students to download. Everybody pretty much has one smartphone per household nowadays. म्हणजे I understand that not every student will have their own smartphone, but typically घरात एक अँड्रॉइड डिव्हाइस असते शक्यतो, आणि मग त्यांना म्हणायचं की तुम्हाला जेव्हा वेळ मिळेल तेव्हा तुम्ही जाऊन फोटो काढा अँड जस्ट टेल अस, किंवा ग्रुपमध्ये काम करायला लावू शकता आणि ग्रुपमध्ये एक तरी अँड्रॉइड डिव्हाइस आहे कोणाकडे असं बघून आपण मुलांचे ग्रुप्स करू शकतो. सो गेटिंग स्टुडंट्स टू रिपोर्ट देअर डेटा, व्हॉट दे ऑब्झर्व इज व्हेरी इम्पॉर्टंट. शेवटचा पार्ट आहे 10 मिनिटाचा, सिम्युलेशन्स विषयी मी थोडंसं बोलणार आहे, ज्याच्यामध्ये तुम्ही सांगितलेलं की सिम्युलेशन्स विषयी ऐकायला तुम्हाला आवडेल. सो 4 वेबसाईट्स आहेत इथे की ज्या फ्री आहेत. सो सिम्युलेशन्स म्हणजे काय? फर्स्ट ऑफ ऑल, सिम्युलेशन्स म्हणजे कॉम्प्युटरद्वारे एखादा प्रयोग करून बघणं, आणि कॉम्प्युटरचा वापर करून instead of actually doing the experiment, you will get to see experimental results from this same simulations. So पहिली वेबसाईट आहे ती fet.colorado.edu आहे. तर त्याच्याविषयी मी थोडंसं बोलते. सो फेटची जी ही वेबसाईट आहे त्याच्यामध्ये खूप छान सोप्या शब्दात किंवा सोप्या विषयांवरती त्यांनी हे मस्त सिम्युलेशन्स ऑलरेडी बनवलेले आहेत, फिजिक्स, केमिस्ट्री, मॅथ्स, अर्थ सायन्स, बायोलॉजी. काही ट्रान्सलेटेड सिम्युलेशन्स पण आहेत, म्हणजे मराठी, हिंदी, गुजराती, इन ऑल ऑफ दीज लँग्वेजेस you can use those if your students are having language problems. So आता मी समजा म्हणलं की फिजिक्सचे मला सिम्युलेशन्स बघायचे आहेत, तर फिजिक्स मध्ये पण टॉपिक्स बघा, मोशन, साऊंड वेव्स, वर्क, एनर्जी, हीट, क्वांटम फिनॉमिना, लाईट, इलेक्ट्रिसिटी, खूप जे आपण नेहमी वापरतो किंवा नेहमी शिकवतो अशा गोष्टींचे सिम्युलेशन्स आपल्याला इथे दिसतात. लेट मी जस्ट शो यू वन सिम्युलेशन जस्ट फॉर डिस्कशन. सो कुठलं घेऊ? सो ऑप्टिक्स मध्ये पण आपण बघू शकतो, आणि बेंडिंग लाईट समजा आपण म्हणलो की वन सेकंड, हा लेट मी फाइंड दॅट सिम्युलेशन, की आपण वी टिपिकली टॉक अबाउट प्रिझम्स अँड हाऊ दे बेंड लाईट्स is a very common phenomena in our teaching, right? This is something. So if I now see the simulation, what does the simulation really make me do? Is that it will give me some scenario in which I can actually do an experiment. So आता मी समजा prisms विषयी experiment करायचं म्हणलं, typically in lab we have only the triangular prism, but can I take a circular prism for example and then see how the light bends? So now in this case the environment is also air and the starting thing is also air. So if I change it to water, it bends a little bit, or if I change it to a mystery thing, it will change. Or what I can also do is see that if I change the position of my prism, how the light ray really changes. I could do the same thing with a regular triangular prism, right? So how does it change? Or you could also see if the prism medium is made up of glass, मग काय होईल? No, so right now I'm changing the environment. You could also change the medium of the prism that you can change. So ऑब्जेक्ट्स मध्ये मी आता इथे ग्लास प्रिझम घेतलाय, पण मी समजा पाण्याने भरलेला प्रिझम घेतला असता पाण्यामध्ये, तर तो लाईट रे स्ट्रेट गेला असता. और फ्रॉम वॉटर टू एअर जाताना कसा बदलेल, you know? So all of these different things. What if I place another prism next to it? Will it change? I change, place one more. So all of these things students can explore on their own. This is completely free. Even if they don't have a computer at home, if there is one computer in your college in which you can download these, you don't need an active internet all the time. You just need to download it once and load it on the computer, and students will be able to explore it on their own. So very often for colleges that do not have a lot many computers, what we have done is also there is only one computer that the entire class uses, but the class will decide what experiments they will do. They will, perform these simulations and write down results and share it with the class. So that kind of teaching can be done. The best part about PhET is, as I said, it is free. It is downloadable, so you can download this particular simulation. You don't need active internet. You can also log in as a teacher. So if you go, you can create a sign-in account for a teacher, and you will be able to see teaching resources for your class. की कुठले प्रश्न विचारायचे, what kind of teaching process should I follow, what kind of questions should I ask the student. So all of these teaching resources or teacher tips are also available. So this is a wonderful website, has multiple simulations. Definitely try these out. Again, you don't need fancy equipment. You just need one computer somewhere in college that the students can really use. The next website that I want to talk about is called as CT STEM. It's by Northwestern University. This is a little different from PhET, but again, it's a simulation-based website. So if you see, you have to first register as a teacher. In PhET, you don't need to register as a teacher. You can, directly go and use the particular simulation. But in CT STEM, you're, going to use a lesson. And for that, you need to first register as a teacher. स्वतःचा अकाउंट काढायला लागतं आणि मुलांना रजिस्टर करायला लागतं ऍज अ स्टुडंट. सो हे दोन्ही करायला लागतं. बट खूप सोपं आहे. जस्ट ऍज यू ओपन एनी ईमेल अकाउंट, इट इज ऍज सिम्पल एज दॅट. आता ह्याच्यामध्ये आपण बघायला गेलो तर देर आर व्हेरियस काइंड्स ऑफ करिक्युला अवेलेबल. देर इज various curriculum things, right? So you see biology, chemistry, engineering, environmental, mathematics, physics. There is also theory building. There is also social sciences. There are some really nice social science experiments here on CT STEM. मग एखादा CT STEM चा experiment कसा असतो? So for this, the teacher is not present with the student, but this is more like a homework. And the student is given directions. The students are told to work through. And ते वाचून स्वतः सॉल्व्ह करायचा प्रयत्न करतात आणि टीचर्सना त्याची उत्तरं मिळत जातात की मुलांनी कशा पद्धतीने सॉल्व्ह करायचा प्रयत्न केलाय. सो इथे आता हा वुल्फ आणि शीपचा प्रॉब्लेम आहे की ज्याच्यामध्ये एखाद्या इकोसिस्टीम मध्ये इतके वुल्फ्स आहेत, इतके शीप्स आहेत आणि इतकं ग्रास आहे, तर कशा पद्धतीने वुल्फ आणि शीपचा नंबर व्हेरी होईल हे त्यांनी विचारलंय. सो त्याच्यामध्ये असं सिम्युलेशन असतं आणि ह्या कसं वापरायचं ह्याची माहिती सगळी वरती दिलेली असते. आणि बरेचदा आपल्याला वाटतं की मुलांना हे स्वतः येईल का करता. सो द ट्रूथ इज दॅट स्टुडंट्स आर वे बेटर एट युझिंग सिम्युलेशन्स देन अस. They are born and using computers and internet, mobile way better than us. So मी आता सुरुवातीला सेटअप करू शकते आणि इथे तुम्हाला दिसेल काही वुल्स आहेत, काही शीप आहेत. When I say go, ते शीप आणि वुल्स एकमेकांना भेटणार आहेत आणि त्यांचे पॉप्युलेशन्स व्हेरी होत जाणार आहेत. मग आता तुम्हाला इथे ग्राफ पण दिसतोय की कशा पद्धतीने शीप बदलतायत, त्यांचे नंबर कशा पद्धतीने, वुल्फचा नंबर बदलतोय, ग्रासचा एरिया बदलतोय. सो हे सगळं मुलं स्वतः करू शकतात. त्याचप्रमाणे आता मी ह्याच्यात बदल करू शकते. म्हणजे मी आता समजा स्टॉप म्हणलं आणि मी आता नंबर ऑफ इनिशियल शीप मी समजा वाढवला, परत सेटअप केलं, गो केलं, तर वेगळी उत्तरं येणार आहेत. आता मगाचा ग्राफ आणि आत्ताचा ग्राफ ह्याच्यात खूप फरक आहे. आणि मग ह्याच्यामध्ये खाली प्रश्न पण विचारता येतात. ऍज अ टीचर यू कॅन आस्क क्वेश्चन. मग सुरुवातीचे प्रश्न अगदी सोपे असतात की लाल लाईन काय दाखवतीये, ब्लू लाईन काय दाखवतीये, किंवा काय प्लॉट केलं जातंय या ग्राफ मध्ये. बट इफ आय गो टू अ नेक्स्ट लेवल और द लेवल आफ्टर दॅट, स्लोली the difficulty level of questions increases. So in the second level, for example, the particular problem asks about की कोणतं पॉप्युलेशन पहिल्यांदा इन्क्रीज होतं, का असं होतंय, why do you think this is happening. किंवा मी डायरेक्ट समजा चौथ्या लेवलला जाऊन बघितलं तर चौथ्या लेवलला त्यांनी एक चॅलेंज दिलंय की युअर चॅलेंज ऍट दिस पॉइंट इज टू टर्न द अनलिमिटेड ग्रास इंटू अ स्टेबल सिस्टीम. सो आता मुलांना विचार करायला लागेल की स्टेबल इकोसिस्टीम म्हणजे काय, आणि मग अनलिमिटेड ग्रासला मी स्टेबल इकोसिस्टीम मध्ये कसं करू शकते ऍटलीस्ट 300 टिक्स साठी. सो स्लोली द लेवल ऑफ क्वेश्चन्स गोज ऑन इन्क्रीजिंग and the students have to think through it. Also, when they enter their answers here, you can see what they have entered. So for example, if I say something here, as a teacher, you can see that what your student has entered. So some really brilliant resources are out there. The question is whether we are using them and how we are using them. The brilliant part about CT STEM or any simulation is that the experiments that you cannot do in lab. So for example, this wolf versus sheep experiment, if I'm an ecology teacher, I cannot do this in real life, but on computer I can make my students visualize what could be happening, and it will be an important learning experience for them. So that's about the simulations, and you can definitely try the other two simulation websites. I really encourage you to try Amrita Virtual Labs. This is an Indian website. Very many different from syllabus experiments are there. Lab Exchange is also a great website. So do try these out and try it for yourself. I'm also giving some reading resources for each subject that, in sciences especially. You can have a look at all of these. These are some really nice educational resources that you can read. And also some apps that you can try for evaluation, different apps that you can try for brainstorming, concept maps, rubrics, for evaluation, as I said. You can try some nice things like Peer Grade or Ruby Star. So why I'm not spending more time on these things is that the slides will be with you. And more importantly, you need to try one app and see if you like it. If you don't like it, go to another app. So for example, for quizzes and polls, जर का Mentimeter नाही आवडलं तर Socrative try करा. ते नाही आवडलं तर Class Marker try करा. So you have to choose what works the best. So technology is the last thing, as I said, the 5th step. But you need to choose which one works for you and see it for yourself. So that's why I'm not spending much time. And with that, I hope that we are creating an inclusive classroom that, has multiple learning activities, different types of, so for our students, because they come from different socioeconomic backgrounds, they have different personality traits, they have different learning abilities. So ह्या सगळ्यांसाठी आपण एक छान सबका साथ सबका विकास आपण करू शकतो का is the question. So thank you so much for giving me an opportunity to share some things with you. Most of these things we have tried. If you have any questions, we'll be very happy to help you with implementation. की मला सिटी स्टेम वापरायचंय पण इथे इथे प्रॉब्लेम येतोय, प्लीज कॉन्टॅक्ट अस, विल बी व्हेरी हॅपी टू हेल्प यू. Or I want to try enquiry on this particular topic. How should I proceed? I'll be very happy to share some resources with you. So thank you so much. It was great, interacting with all of you.
Thank you, madam. So now I request all the participants, if you have any question, then you can ask the question related to this talk. I request all the participants, if you have any questions related to this talk, then you can ask.
प्रश्न विचारा, काही टेन्शन नाही. आणि तुम्हाला आता नसतील विचारायचे तर नंतर मला कळवले तरी चालेल. मी माझा ईमेल इथे चॅट मध्ये टाकून ठेवतीये, मला सर पण देऊ शकतील नंतर. मला नक्की ईमेल द्वारे पण प्रश्न विचारू शकता नंतर.
Okay, thank you, ma'am. There is no any question from participant. So thank you, ma'am. The session was very enlightening and it will definitely help us in the developing new insights into the domain of pedagogical tools and techniques for improving our learning outcomes. You have beautifully explained all these things in a very simple manner with very simple examples. So thank you once again. Now I would like to request IQAC coordinator, Dr. S.D. Chavan sir, to deliver presidential address of this program.
Thank you very much, Dr. Kade sir. The proposed chairperson of this online workshop, Principal Dr. D.V. Gore sir, and the eminent scholar, the studious person, the greatest source of knowledge, and a committed teacher and a resource person of this workshop, Honorable Dr. Nirja Dashputre ma'am, the coordinator of this workshop, the head of the chemistry department, Mr. Pawan Kadam sir, his colleagues, and the person who is comparing this session, Balasaheb Kade sir, and his colleague, Dr. Birade sir, all faculty members of our college, as well as all faculty members who joined this webinar with the help of Zoom meeting as well as YouTube. Let me thank to this online platform like Zoom and Google Meet, because only with the help of this Zoom platform, we could avail the lecture of such a great person in the field of education, ma'am who has been giving her best in the field of education, and with the lecture that she delivered before us, we could come to the conclusion that how really she has worked on this issue very seriously and how she has been doing well in this department as far as teaching learning process is concerned. It is said that the development of human civilization brings transformation in education, and these transformations lead to new challenges in the process of teaching and learning. And these challenges lead to the evolution of more effective and pedagogical tools. It means that if we are not alive to the changes around us or the transformations around us, probably we would not be able to cope up with the challenges in the field of teaching and learning process. So instead of sticking up to that stereotype teaching methods, it has become now very necessary that we must adopt some new teaching methods so that we can entertain the student in the class with the help of the teaching methods, the tools, the methodologies that we have been using in the class. It is our ardent duty to make the student understand what we have been teaching. Madam had rightly pointed out in the very beginning of our lecture that the person said that I taught him, but I do not know whether he learned it. So it is the question of introspection, that is this the same happening with us, that we have been teaching in the classrooms, but are the student getting it? Are the student understanding it? So this is the time that we must collect the feedback at the time of teaching when we have taught some topic in the classrooms. Because it should not be a one-way traffic that we have been just teaching. It is not just for the sake of our satisfaction, but we teach for the satisfaction of the students. So how can we get the satisfaction of our teaching? Madam had rightly pointed out some methods, some approaches, some techniques that can be used by the teachers in their classroom to make the topics easy as well as informative for the students. Because unless the students get the knowledge properly from the topic that they have been taught in the class by the teachers, probably the interest would not be created in their mind to learn another one. So whatever methods Madam has pointed out or given us in her lecture to make our lecture more effective are really very, very important and essential to make our pedagogy more effective. Otherwise, we cannot cope up with the challenges that are before the student. As Kadam sir has rightly pointed out in his introductory remark that we have been living in the age of Akash and Baijus. Students are following the lectures of physics wala instead of going into the classrooms. I saw many students engaging in the YouTube lectures and they have been following physics wala because they have been finding it easier than the classroom teaching. So isn't it a challenge before us that shouldn't we not make our lecture more interesting than physics wala and the lectures being delivered by the Akash and Baiju or the other institute like Unacademy and Vedantu? So these are all the challenges before us. That's why we should change ourselves. And this mutability in the field of education, this mutability in the field of this pedagogy is really very, very important. On the one hand, we have been talking about education policy. On the one hand, we have been talking about the transformation in the education field. But simultaneously, we must also be aware that how we can tackle this problem, how we can tackle these changes, how we can cope up with these changes. And I'm sure that whatever points, whatever techniques, whatever pedagogical methods that Dashaputre Madam has intimated with us are really helpful for all the teachers, not only to the science teachers, but also to all faculty teachers, because the website like FATE is really important for all the people, and other websites are also important for the teachers. So I express my sincere thanks to Honorable Dashputri ma'am on behalf of this institution for spending this valuable time for us. And she has also given her mail ID as well as phone number, that if anybody wants to ask any question with respect to this topic, because she herself is very interested in this topic. Otherwise, we know that the people who normally deliver such type of lectures, they are not interested to have any talk with you after the lecture is finished. But ma'am has given you her phone number as well as email ID because she has really been interesting in this topic since a long time, and her profile shows that how much committed she is to this profession. So I congratulate ma'am on this enlightening speech. I express my thanks to you. I congratulate Pawan Kadam sir for organizing such a enlightening session for the teachers and for giving me the opportunity to be a part of this session. With this remark, I stop here. Thank you. Thank you very much.
माझा फोन नंबर एक मिनिट चॅट मध्ये फक्त आलाय की माझा फोन नंबर आपल्या व्हॉट्सअप ग्रुप वरती आहे. I am there. If you share your queries there, other teachers can also learn from those questions. So let us try to form a community. आपल्याला सगळ्यांना एकत्र काम करायचंय. So let us try to form a community that will help each other. So individual questions विचारण्यापेक्षा it would be great if we can ask in the group so that others can also learn. The other thing is we would very much love if you come to ISER. So one of the ways that we invite teachers is through our MSFDA workshops. So please enroll for the MSFDA workshops. I've also put in the information on WhatsApp group. When you come here, there is even more interesting things that we can do together. And let's build up this rapport. As sir said, we have to work together to solve the problems in education. Thank you, sir.
Thank you, ma'am. Thank you, sir. At last, I invite Dr. D.R. Birade, sir, to propose a vote of thanks of this program.
Thank you, sir. Very good afternoon to all our most valued guests, our teachers, and all the participants of this online workshop on effective pedagogical tools and techniques for improved learning outcomes, organized by Department of Chemistry and IQAC, Sri Venkatesh Arts, Commerce and Science College, Devagaraja. I would like to take this opportunity to express my gratitude and propose vote of thanks on this occasion. As a member of organizing committee, on behalf of our college, first of all, my sincere thanks to the chief guest and resource person, Dr. Nirja Dashputri Madam, Principal Technical Officer, Education Department, ISER Pune, for her interesting, informative, and knowledgeable program. Thank you, Madam. I would like to propose 30 vote of thanks to Dr. Sudhir Jawan, sir, Head Department of English and IQAC Coordinator. Thank you, sir. Further, a big thank you for our Principal, Dr. Nyanechar Gori, sir. I extend my sincere thanks to all the delegates, teachers who have joined this online workshop. Last but not least, I would like to express my special thanks to Dr. Pawan Kadam sir, Head Department of Chemistry, all committee members, Dr. Kale sir, and all the faculty members from our college for their help. Thank you to all. And with due permission of principal sir, I will hereby declare that this online workshop is over.